Okay, in this video, we will talk about the alternating current through a resistor, an inductor, and a capacitor respectively. So let's look at the alternating current through a resistor first. Okay, alternating current through a resistor. This is a alternating current source. This is a resistor. And then the Kirchhoff's second law tells you that V minus IR equal to 0. You still remember what is Kirchhoff's second law? Kirchhoff's second law states that the sum of all the potential change in a closed loop of a circuit is equal to 0. Therefore, V minus IR equal to 0. Then V equal to IR. If now you are given that the supply voltage to be in this form, by using the formula V equal to IR, you know that I equal to V0 over R sine omega t. And then V0 over R is just a constant because V0 is a constant and then R is also a constant. Then you say this is I0. This is the amplitude of the current. Then I is of the sine function. So you look at this. When V is sine function, I is also sine function. If V is cosine function, I is also cosine function. So what you can conclude is that alternating current voltage across the resistor and the alternating current in the resistor are in phase. That means that there are no phase difference between the alternating current voltage and also the alternating current in the resistor. So you want to find an instantaneous power. That means that the power at any time t. P equal to Vi. Then you substitute V and I into the function. Then you can get P equal to P0 sine square omega t. And then P0 is equal to V0 I0. That means that the maximum power is equal to V0 I0 is equal to I0 square R is equal to V0 square over R. You still remember that Vrms equal to V0 divided by square root 2? You substitute that formula inside. Then you can get P0 equal to 2 Vrms IRms equal to 2 IRms square R equal to 2 Vrms square over R. This is the instantaneous power. When you want to get the mean value of the instantaneous power, you use this method. Okay? This bracket means mean value. Mean value of sine square function is half. So you know that the mean value of the power is equal to the half of the maximum power. That means that whatever answer you have got for the maximum power just now, you divided it by 2, then it becomes your mean power. So you know that mean power equal to Vrms IRms. You still remember the root mean square value meaning? That means the root mean square value of an alternating current is equal to the value of a constant direct current which can produce the same heating power as the alternating current in a given resistor. So, mean value of the power is the power that will be dissipated as heat. Mean power equal to Vrms IRms. So this fits the definition of the root mean square value exactly. So now you need to remember these two because they really often come out in the examination. That means that you need to remember mean power of the resistor is Vrms IRms. Or you can also express it in terms of the V0 I0, which is V0 I0 over 2. Then the maximum power of the resistor is V0 I0. Okay, so now we continue. Okay, you know that the power is sine square function when the V is sine function and I is sine function. So you can plot them on the same graph. V is sine function, I is sine function. So the P is sine square function. Okay, and then this is the phasor diagram. That means that they are sine function, so they are in this direction. Okay, the power is sine square function, so it cannot be expressed in the phasor diagram. The phasor diagram can only express the positive and negative sine and cosine function only. If this is sine square function, then I cannot express it in terms of phasor diagram. Okay, so you know that for the resistor, V and I are in phase. So for the alternating current through an inductor, you also use the Kirchhoff's second law, and then you know that V plus the back EMF of the inductor equal to 0. Then V equal to L di dt. So if you are given V equal to V0 sine omega t, then you can do your integration to get the function of the current. If V is sine function, I is negative cosine function. If V is cosine function, I is positive sine function. So you know that in an inductor, the alternating voltage across the inductor leads the alternating current in the inductor by 60 degrees or pi over 2 radian. Okay, when V is sine function, I is negative cosine function. So I plot them here. When V is positive sine function, I is negative cosine function. Then the instantaneous power is P equal to V times I. So you know that P is negative sine function, and then the omega, that means that the angular frequency is doubled. That means that when the voltage has made one oscillation, the power already made 2 oscillations. Okay, power is negative sine function, so it's like this. On the other hand, if V is given as this function, I is this function. So you also can plot them on the graph here. And then you also need to remember that the instantaneous power now becomes the positive sine function. Just now is negative, now is positive. And then the angular frequency also doubles. So just now is negative sine function, now is positive sine function. And then the purpose of me doing this 2 graphs is that I want to let you guys know that it is really the same. Because if you look at this, when the voltage is like this, the voltage is like this. When the current is like this, the current is like this also. And then the power is also like this. That means that they are actually the same graph. The only difference is that they started at a different phase angle. But then no matter how you are going to do, the results for the alternating current through an inductor is that the voltage will always lead the current by 90 degrees. And then normally this is given in the question. That means that the question will say that the voltage supply is in this form or in this form. Okay, so now just now you get P equal to negative P naught sine 2 omega t, and then P equal to P naught sine 2 omega t for the two different cases. You want to know the mean value of the instantaneous power, then you use this kind of method. The mean value for the sine square is half, but the mean value for sine function or cosine function is 0. That means that the mean power for the inductor in an alternating current is 0. That means that they will not dissipate any power. There will be no heat lost in an inductor. Because when the instantaneous power is positive, the inductor is absorbing the power from the alternating current circuit, and then the energy is stored inside the inductor as magnetic field. But when the instantaneous power becomes negative, the inductor is releasing the power back to the circuit, and hence all the energy stored just now is released back to the alternating current circuit. So whatever energy you have gained, you will ultimately lose it to the circuit again. Therefore, the mean power is 0. So the energy stored in the inductor is half Li squared. That means that when the current is maximum, the energy stored in the inductor is maximum. Okay? Now I want to introduce to a new variable called reactance. Reactance of inductor is the opposition to current by an inductor in an alternating current circuit. This is the definition that you will give in your examination when you are asked the definition of the reactance of an inductor. Reactance of an inductor XL is equal to the peak voltage across the inductor divided by peak current of the inductor, which is V0 divided by I0, which is equal to Vrms over Irms. Okay, may I know what is the value for the I0 just now? I0 equal to V0 over omega L. I0 equal to V0 over omega L. So you substitute I0 equal to V0 over omega L, then you can know that XL equal to omega L equal to 2 pi FL. So you know that the reactance of an inductor is directly proportional to the frequency of the alternating current. Okay, so now let's go to the alternating current through a capacitor. You still remember the formula for the capacitance, which is C equal to Q divided by V? You use this formula. You differentiate it. When you are differentiate a function like this, you know you are doing the partial derivative. But then because the capacitance, which is, the capacitance of a parallel plate capacitor is E0 over A, E0 A over D, that means that the whole capacitance is just a constant. So there is no difference in capacitance. So DC equal to 0. And then only you get I equal to C dV dt. Normally in school, you straight away learn I equal to C dV dt. You already skip this part. But I really want to show you all these steps so that you can appreciate the simple formula like this. If you are given the voltage supply to be in this form, then the I will be like this. You do your differentiation. If V is in this form, then the I will be in this form. So you know that the alternating current across a capacitor leads alternating current voltage across the capacitor by 90 degrees or pi over 2 radian. Okay? Of course, if you don't want to use the word lead, you can also use lag behind. That means that just now is current leads voltage by 90 degrees. So you change the sentence. It becomes voltage lags behind current by 90 degrees. Okay. You also plot the graph just like what you have done in the section just now. If V is in this form, I is in this form, then the instantaneous power is in this form. The angular frequency also becomes doubled. For here, the same procedure happens. So you also plot the graph. And then I still want to show you that they are actually the same graph. When the V is like this, the V is like this. When the I is like this, the I is like this. When the P is like this, the P is like this. So you know that they are really the same graph. The only difference is that they started at a different phase angle. So you still do the same procedure. That means that you find the mean power of the capacitor is equal to 0, because when the instantaneous power is positive, the capacitor is absorbing power from the alternating current circuit, and then the energy is stored inside the capacitor as the electric field. But then when the instantaneous power is negative, all the energy just now is released back to the circuit. And so in one complete cycle, there is no energy, there's no net power in the capacitor. So you know that there is no heat lost in the capacitor, because the mean power in the capacitor in an alternating current circuit is 0. Okay, so the energy stored in the capacitor is half CV squared. So you know that when the V across the capacitor is maximum, the energy stored inside the capacitor is maximum. Okay, which is opposite of what we have learned just now, because just now for the inductor, the formula is half Li squared. So for the inductor, when the current is maximum, then only the energy stored in the inductor is maximum. But now is in capacitor, so you know that when V is maximum, the energy stored inside the capacitor is maximum. Okay, I also want to introduce to a new variable, which is Xc, the reactance of the capacitor. Reactance of capacitor is equal to the opposition to the alternating current by a capacitor in an alternating current circuit. So Xc equal to V0 over I0 equal to Vrms over Irms. Okay, what is the value of the I0? I0 equal to omega CV0. I0 equal to omega CV0. So you substitute I0 equal to omega CV0 here. Then you know that the reactance of capacitor equal to 1 over omega C, which is 1 over 2 pi Fc. So you know that the reactance of capacitance is inversely proportional to the frequency of the alternating current. But sometimes we prefer to do a meaningful graph whereby you can get the gradient. Therefore, we change the f to 1 over f. Then you can get a straight line graph. Okay. So remember the formula for Xc equal to 1 over 2 pi Fc. The formula for the XL is XL equal to 2 pi FL. Okay. So this is a summary of what you have learned about the maximum power and the mean power just now. For the resistor, the maximum power, or we can also call it as peak power, is known as P0. P0 equal to V0 I0. The mean power or average power, which is the power that will be dissipated by as heat, is mean power. And then it is half of this value. Normally, I memorize these 4 things. That means that I memorize the peak power for resistor is V0 I0. The average power for the resistor is V0 I0 over 2. Then this term, you move it here and also here. That means that the maximum power of the capacitor and inductor is V0 I0 over 2. And then the mean power for capacitor and inductor are 0. So next time when you see a circuit like this, that means inside one alternating current circuit, there is a resistor and a capacitor and an inductor. You know that the only component that will dissipate the heat is resistor only, because only the resistor has mean power. The other components has no mean power at all. Okay, so after learning this, you should know that When V and I are in phase, then we are sure that the component is resistor. If the current leads voltage by 90 degrees, we are sure that it is a capacitor. If the voltage leads current by 90 degrees, then we are sure it is an inductor. So these are often the questions that come out in the examination. Please don't get it wrong. Okay? Resistor is that they are in phase. Capacitor, C means current, so current leads voltage by 90 degrees. And then inductor, in the inductor, the voltage leads current by 90 degrees. In the following video, we will talk about the Q&A of this section. Okay? Thank you.